Welcome to the first event in our Food Sustainability and Innovation Series. We very much appreciate you coming. My name is Sally Greenwood, and I'm the Vice President of Communications and Education for Genome BC. And before we get started, I thought I'd just give you a couple of lines about Genome BC for those of you who aren't familiar. So we lead genomics innovation on Canada's West Coast and facilitate the integration of genomics into society. We're a recognized catalyst for government and industry, and we invest in research, entrepreneurship, and commercialization in life sciences to address challenges in key sectors such as health, forestry, fisheries, aquaculture, agri-food, energy, mining, and environment. We partner with many national and international public and private funding organizations to try and drive BC's bioeconomy. One of the reasons that we do talks like this is because we are very, very committed to fostering an understanding and appreciation of life sciences among teachers, students, and the general public to enable the uptake of technology, the understanding of technology, so we're really glad you're here. I am really honored and have the distinct pleasure of introducing our moderator for this series, Moira Quayle, who has too numerous credentials to cover fully. Her bio is attached. So I'm just going to mention a few. She's currently the director of the Liu Institute for Global Issues at UBC and professor in the Sauder School of Business and overseeing the D Studio, which she can tell you more about later if you want. Co-director of the new Master of Public Policy and Global Affairs, Having Fun, Evolving Policy Studio. So the panelists have been warned, she might ask policy questions. Moira was the Dean of Land and Food Systems, which is now led by renowned panelist Ricky. So Ricky is also here to lend his expertise. Don't look at me so shocked. You actually are here to do that. After her time as Dean, Moira was the Deputy Minister of Advanced Education, during which she had the privilege of being an observer on the board of Genome BC, which sparked her continuing interest in the role of genomics in society. And as a result of that, she is the Vice Chair of Genome Canada and will assume the chair's position later this year. Moira is most comfortable at the intersection of all sectors, academia, business, government, and civil society, and enjoys moderating evenings like this. So don't disappoint her, but behave. We're grateful to have her here tonight, and I'm going to hand it over to Moira. Thanks very much.
Good thing I go to the gym every day so I could step up here without any hassle. Well, good evening. It's a real pleasure to be here. Can you hear me, or do I need to change the mic? Is it all good? Okay. Before going any further, I wish to acknowledge that we are meeting on the traditional, ancestral, and unceded lands of the Coast Salish peoples, who have called this area home for many thousands of years and continue to do so today. So there's probably nothing more important than food in our lives and all that goes with it. The need for clean water, the social aspects of sharing food, and how we accommodate and think about the environment, climate change, and the challenges that come with that. As Sally mentioned, this is the first in a series of 3 events over the next few weeks, that are addressing various aspects of food with a real focus on innovation and sustainability. So how do we move forward? So tonight, the topic is environmental farming footprint and climate change. And we're really fortunate to have 4 very engaging and diverse speakers. When you came in the door, you received a flyer with bios of our speakers. So I'm assuming you've read those, and we'll get right into the action. Tonight is a real opportunity to hear different perspectives from our speakers, from all of you. And it's really a time for open and respectful dialogue and conversation. And I plan to moderate in a way that we all practice good listening and respectful timekeeping. So in order to allow more people to speak when we get to the Q&A time, we'd really appreciate it if you keep your comments and your questions relatively short and succinct. Okay, a few housekeeping items. Washrooms, out the door, left, turn right, and you probably saw them on your way in. Exits. I've been hanging around with mining folks lately, and they're very rigid and smart about giving emergency exit instructions. So should there be an emergency when we're in here, exit out those doors, turn right, and you'll see at quite short to the end of the hall, 2 exit stairways. So that's our emergency exit. Last point of housekeeping, phones off. Oh, yep, it's always good to have that reminder, isn't it? It's hard to, So we're going to handle everything as simply and efficiently as possible to maximize the dialogue time, and we'll be finishing at 7 p.m. sharp. So any of you that have other engagements, don't worry. The speakers will be in the following order. We start with Ricky, we move on to Randy, then to Parm, and then Lauren. They're going to speak here from the podium for around 10-ish minutes, some less, some potentially more. And you'll need to note down any questions that you may have. We'll engage all of those in a kind of panel format after our 4 speakers have spoken. And then the speakers and I will come back and get comfortable on the stage. I think this is when Sally brings out the gin and tonics, but I'm not entirely sure whether that's in the format. Anyway, then we'll get into dialogue, and there'll be a mic. This mic is going to move here for you to come up to the front, and we'll of course practice respectful cueing and I'll call upon you and get the dialogue going. Okay, I think we're set. Ricky, are you ready?
I think so.
Okay, here you go.
Thank you. Ooh, obviously I didn't go to the gym like Moira. So thank you very much, Moira, and thank you, the Genome BC people, for... Oh, great, thank you. I'm just finding the shelf here. I did wear my best summer shorts, and somebody asked me, what do you wear during the real summer? And they said, do you wear long pants? And I said, well, if you take the logical extension of shorts and let your imagination go wild, you can think of what could happen. And I said, I'm not that cruel. So thank you very much. I'm supported by 3 wonderful speakers that follow me, and what I'll do in the next 10 minutes is give you kind of an overview of some of the issues, challenges, and opportunities that I see from an ag school. And I'm really, really honored to follow Moira, because Moira left me big shoes. She was my predecessor. In fact, she was 2 deans ago, and she left me with a wonderful faculty, so thank you, Moira. So let me try to see if I can get this going here. So let me go back. Opportunities. Oops, I think we went. Okay, it was really supposed to be issues first. Let me talk about some of the issues that we're all facing, and I think some of these are not surprising to you. You know, if we talk about population growth, and we've heard a lot about this argument in 2050 that we're going to be having to look after 9 billion people, and how do we feed 9 billion people? You know, and what are some of the strategies that we're going to have to use for 9 billion people? Do we grow more food? Do we look at alternative strategies to preserve food and reduce our food waste? I think these are all kind of issues that we're going to have to look at. Demographics of farming. You know, I saw a demographic report of farming in Canada, and it's reported that about 50% of the farmers now have an average age of over 50. And so this is reflective, I think, of my generation, the baby boomer generation. And so we're seeing a lot more of these people move through the system. And we're challenged now with how do we replace our farmers and some of the issues that are entailing farming. You know, high land prices, especially in BC, which is restrictive to young people getting back into farming. Aging population, I've talked about that. I'm a baby boomer. And, you know, I think of my time as a teenager where I think the operative word was invincibility. And now as I approach my age, I'm thinking, gee, I'm vulnerable. And I'm scared of dying, and I'm scared of getting sick. You know, so the dynamics have really changed. Urbanization, holy crow, you look all over the place how the rural landscape has diminished at the expense of urbanization. And so we're going to be looking at issues around urban agriculture. How do we produce food for an urban population? Are we going to have to go to rooftop gardens, vertical gardens, sort of these vertical towers, these condos? Those are issues that I think we'll be looking at. The local food movement, well, BC was one of the first to get into the 100-mile diet. And so we're seeing this pervasive right across the country, across the globe. Globalization, of course, is another thing. Trade agreements, we just finished the rounds of the TPP. And what impact will that have on agriculture and the way we manage agriculture? Climate change, of course, we've all heard about climate change. And it'll be interesting to see what grows in BC in a few years. I often say that, maybe oranges will be growing in BC, right? Something that 10, 20 years ago we would have never imagined. The organic versus conventional market, right? And you see now just rows of organic produce. When I was a child, no, it was conventional. Food, nutrition, and health. You talk about an issue that has come to the forefront with regards to these issues. Now people are really concerned about what they eat and the impact it has on their health status. We've heard a lot about sugar, fat, and cardiovascular disease, obesity, diabetes. So that's a big issue. Food safety, I think there isn't a day in the paper that doesn't go by where we don't see a food safety issue with regards to a food poisoning issue. And so how do we manage that now? And then, if we talk about security, sustainability, and environmental sustainability, we need to think about those issues. But I think more importantly, we have to think about nutritional security. It's not only good enough to produce more food, but we need to produce sound food that is nutritious for our population. New technologies, wow, this goes back to even when I was a child, and things like irradiation. And, irradiation was meant to be the means to preserve food and to give us that long shelf life extension. But then there was concerns about what happens if I eat these foods. And we've seen the debate continue on with GMOs, and I do some work with nanotechnology. And I think Randy's going to be talking about this issue with regards to consumer perception, regulatory issues around those new technologies. I don't think it'll go away. As we develop new technologies, we'll be facing these issues. And then social media. Again, we're in an era where, Twitter, Facebook, Instagram, again, we've had access to more information than we've ever had in history. But are we a smarter population? I'm not sure, right? Because, as I tell my class in food chemistry, the analogy that I'll use is when I was a kid, you read it in the newspaper, it must be true, right? Now kids are saying, oh, I read it over the internet, it must be true, right? So we're seeing these kind of debates with social media. So let me talk about the challenges. The challenges that we face today, I think, are the regulatory framework. So people want to have the insurance that the food that we eat or the products that we use are safe. And I think there's a lack of harmonization through the global partners in regulating foods and technology. That's a big issue. Consumer education, issues management, risk-benefit analysis, consumer acceptance. Again, I talked about social media and how that affects how we think about technologies and products. Again, we need to do a lot of work in that area. Technology transfer is a big issue in the agri-food sector. There's many good ideas, and the challenge is how do you make them come to fruition in an economically consumer-accepted format? That's a big challenge. Bringing value to the entire food chain. So Parm Baines will be speaking as a grower who I think recognized that it was not good enough to just produce a product. He had to add value to that product. And so how do you bring value to the entire food chain from grower to consumer? And I've talked about food and nutrition security, and I've also talked about environment, soil, and water security. So I'm just going to go back to the opportunities. I think in Canada, we have the wonderful opportunity for branding Canadian products. So if you travel the world, I think one thing that people will say about Canadian products is that they're high quality and they have good food safety standards. So there is that opportunity for us to really capitalize on that. The value add I've talked about, Canada's been traditionally known as a producer of commodities. And what we've usually done is exported those commodities outside of the country and then imported in a value-added product. It makes no sense to me why we're doing that. We need to value add within Canada and then capitalize on that value-added product. New technologies I've talked about, and one of the new technologies I think we're going to be looking more and more at is precision agriculture. So again, you think about how traditional farming was done, right? Where they had the seeder that went down and they hopefully followed a line. Now with GPS, we can precisely plant seeds. We can precisely fertilize those commodities. And so that we hopefully will get maximum yield and ultimate quality. The thing that we've also seen over the last few years is the merging of various technologies. And so this is a wonderful opportunity for great discoveries. And one of the things I've talked to the scientists at UBC about, and this is a colleague in electrical engineering, is about 3D printing. And this is the ability to print things using this machine. And I said, gee, wouldn't it be wonderful if we could actually interface genomics, our nutritional requirements that are based on our own genes, to this machine so that we could actually print food that is personalized for us? Is this something that you would see in the future? And this is kind of Star Trekian, if you think about the food replicator. So this is something that I think we'll see more and more of in the future. And finally, I can't say enough about education. One of the things that we're passionate about is educating not only the consumers, but our young people, because our young people will become our consumers. So we have this wonderful program at UBC, which is called Think and Eat Green, which is a partnership with the Vancouver School Board. And it's actually about community gardens and food literacy. And the essence of that program started when we started to ask children where their food came from. And it was surprising that the concept of something as silly as a spaghetti tree wasn't far off the radar. And so this is about learning where your food comes from and how to prepare your food in a healthy, nutritious manner. So with that, ladies and gentlemen, I'll conclude and I'll turn it over to Randy. Thank you very much.
Hello, everyone. I am Randy Shore. I'm a food issues, science, and sustainability reporter for the Vancouver Sun. And as I am neither a scientist nor a farmer, I'm going to talk about my feelings. And actually, I'm going to talk about your feelings, too. I'll begin with an apology to Sally. She specifically asked us not to talk about GMO foods today, and so that's exactly what I'm going to do, is talk about GMO foods. This is a little talk that I like to call genetic engineering in agriculture, or the greatest public relations disaster in the history of the world. Imagine you had a product that could reduce the carbon footprint of farming, which could contribute as much as a third of all CO2 emissions, that could reduce the need for pesticides and protect farm workers from toxic exposure, prevent child blindness in the developing world, put land-based salmon aquaculture on an equal footing with net pen salmon farms, remove deadly allergens from peanuts. They haven't done it yet, but they're working on it. Now, if you had a product that could do all those things, you'd think you had a pretty good product on your hands. So what if you could alter plants with speed and accuracy without the messy random effects of sexual reproduction? I mean, let's be plain. When you have a baby, you could end up with either a prom queen or a serial killer. These are both possible outcomes. The same is true when you're trying to make a better apple. Some are prom queens, and others are the fruit equivalent of Clifford Olson. Genetic engineering is a more precise way of doing things to plants, making plants do things that they haven't done before, changing them so that we like them better. So you have a process that can do all those things. What if everybody hated it? What went wrong in the story of genetic engineering in agriculture? Now, you could blame Monsanto, and I'm sure many of you do, for being a little overzealous in protecting their intellectual property. They could have done a better job with how they took their fights to court. But really, the PR offensive on the benefits of GMOs, genetic engineering, should have started a decade or two ago, before everyone in the world graduated from the University of Google. Now, thanks to the University of Google, we take advice on science from actors. So what went wrong? Personally, I blame the Koreans. The glow-in-the-dark kitten was possibly the dumbest move ever made by scientists. Without these cats, I don't really know if the term frankenfood is ever coined. Now, farmers, people who are supposed to be stewards of the earth, love these products. They love genetically engineered crops. More than 90% of the corn, soy, sugar beet, canola, and cotton grown in North America is GMO. Farmers clearly don't think these plants are a problem. Scientists, for the most part, are convinced that GMOs are safe to eat. At the WHO, the Royal Academy of Medicine, the American Medical Association, even in Europe, where anti-GMO sentiment is high, the European Commission came out and said they don't have a problem with them. Likewise, the French Academy of Science, and nobody's more opposed to things than the French. But the rest of us are not so sure. Depending on who you ask, GMOs are either the solution to all of the problems in agriculture, or they are the problem with agriculture. Anyone, at any time, can put anything on the internet, no matter how ridiculous it might be. But you could, you could replace one or both of those curves with any number of things, and people will buy it and consume it and pass it along on Facebook. It's kind of maddening. Demand for food free of genetically modified organisms is growing fast, and nowhere is it stronger than in British Columbia. North American retail sales of non-GMO project verified foods have grown more than 300% in the last 3 years, from $1.3 billion in 2011 to more than $5 billion today. Products that display both an organic and non-GMO certification are outselling their competitors 5-to-1 at Whole Foods. Thank you. Please hold your applause for the end. The market share for organic groceries in BC is already double that of the rest of Canada, according to the Canadian Organic Trade Association. The 2013 market report found that 2/3 of British Columbians buy organic foods each week, and more than half of those surveyed said they want to avoid GMOs in their food. An Ipsos Reid poll of 1,200 Canadians conducted for BioAccess Commercialization Centre, a non-profit organization that supports the natural foods industry, suggests that British Columbians are more likely to look for a non-GMO label than other Canadians. We are drinking the Kool-Aid. The Non-GMO Project is a non-profit organization that provides certification of foods made without genetically modified organisms. Now, what started out as a collaboration between Toronto's Big Carrot Market and the National Grocery Company of Berkeley, California, has certified tens of thousands of products. That Ipsos Reid survey also found widespread confusion about which crops, fruits, and vegetables are likely to be the products of genetic engineering. More than 60% of respondents identified strawberries as a product of genetic engineering. Wrong. Only 42% identified tofu as a potentially GMO product, despite the fact that more than 90% of soybeans grown in North America are genetically engineered. So many shoppers are convinced that perfect red hothouse tomatoes are the result of genetic engineering that BC-based Howlings Tomatoes obtained non-GMO project certification. And there are no GE tomatoes on store shelves in Canada. They certified to fight the perception that they were GMO, even though it was impossible. Genetically engineered, or GE life forms, popularly known as genetically modified organisms, or GMOs, are created when the genetic code of an organism is altered to express a desirable trait, or when code containing undesirable traits is silenced or removed. Much of the opposition to genetic engineering of foods is focused on the practice of inserting genetic code from one organism into another, which doesn't happen much in nature. At its heart, genetic engineering is a shortcut that scientists devised to speed up the work of selective breeding of plants into more useful and productive forms, and to resist threats from the environment. Now, some of the speakers that come after me are going to be talking about some of the more specific applications of genomics, which are, it's almost mind-boggling how broadly this technology is being applied. So, let's not be too focused on corn and soy, but, that's where I am, so let's just press on. More than 40% of Canadians agree with the statement that GMOs are unsafe, according to Ipsos Reid. That is based on exactly zero evidence. More than 3/4 of British Columbians profess awareness and understanding of the issues surrounding genetic engineering in the food industry, the most of any province. Many of the poll's findings reveal deep suspicion of the food industry and the willingness of government to protect them from threats. More than 70% of Canadians say they would avoid buying foods containing GMOs. Only 15% of British Columbians who are aware of GMOs believe government would protect them from health risks if they knew of them. We are not a trusting bunch of people. Really, everything about the current food zeitgeist is working against GMOs, genetic engineering, genomics, you call it what you want. The rise of farmers markets, the growing popularity of organic foods, and relationship marketing all make the rehabilitation of genetic engineering a daunting task. When you buy a steak at Whole Foods, the rancher's smiling face is displayed at the meat counter. We want to know the story of our food, how pure and simple it is. We want to eat pure, natural food with a bucolic backstory, preferably involving a scenic valley dotted with red barns and happy cows eating grass in meadows. No one wants to hear the story of food if it involves labs and test tubes. Thank you.
Well, good evening, folks. I'm not a very fast speaker, but I've been mandated to finish my talk within 10 minutes, but I bought myself 5 extra minutes by bribing Maura with some blueberries over the summer. So thank you, people at Genome, for the invitation, and glad to be here. So my talk's going to be a little bit opposite of Randy's, and so I may be the good guy here. So I do need to move fast, but I wanted to give you a sense, a context of the blueberry industry. You need to hear about it, a real success story. It's outdoing, apples used to be our main crop here, but it's not anymore, it's blueberries. So, so my talk, environmental stewardship, we have an organic blueberry farm in Abbotsford, and base my talk mostly on that. So I'm going to talk blueberries, and blueberries, and I have to put in a bit for our sister organization, the USA Industry. It's their 100-year birthday, 2016, so 1916. And strangely, I happen to be the chair for our counterpart, the USA blueberry industry. That's a long story how a Canadian became the chair for that, but we'll keep moving forward. We'll talk about start off with the blueberry production, global, North America, and BC, and move on to our operation, Westbury Farms, then go on to the organic blueberry farming, and then the environmental issues. Now, did I do that? What happened there?
Hit the advance button. Hit the advance button and see what happens. Don't use right behind you.
Nope, somehow. Sorry, for some reason the projector decided it wasn't happy with life.
I guess it doesn't want me to talk.
No, it's pretty quick. So just give us, there we go.
I have to buy another 2 minutes from you.
Those 30 seconds.
Okay, so the blueberry industry in the U.S. started 100 years ago, and the people that worked on it, Elizabeth White was a daughter of a farmer, and Frederick Covell was a breeder, and so they did a lot of the initial work in New Jersey on blueberries. I had to share all this information with you. In the after 1995, 96, you know, when the first health benefits came out on blueberries, the antioxidant story and all that, I mean, there are other crops, fruit that are higher in antioxidant, but everybody follows the blueberries. That's what sticks in their mind as having the higher antioxidants. So the industry just went global. So you can see some of the countries in Europe. You got Chile, Canada as number 3. United States still produces 50% of the production. You see on the right-hand side, 552 million pounds out of 1.1 billion pounds. Total acreage, 247, and the U.S. is 110,000 acres. Total world production, North America, that includes us. We produce over 60% of the total production. You got South America at 22, and Europe at 11. Of that, the fresh production, again, we're about 50%, South America 24, and that's Chile and Argentina. And the total processed production, you can see we're at about 80%. And so, you know, you're getting blueberries around the year now. It's no more the excitement of waiting for BC blueberries. After we're finished, Chile starts out in October, Argentina, then Chile, and they carry you right through until about March, April, and then Florida and other southern states start, and we're the last ones in North America. In North America, just pointing out, BC is part of that. Just look at the acreage. From 2007, we went from 17,000 to, it's almost 30,000 acres now. And we did 152 million pounds last year. 170 million pounds last year. We're looking at doing 200 million pounds this year. 1980, the crop used to be 20 million pounds. We're growing by 20 to 30 million pounds a year now. So that's a lot of blueberries you guys got to eat. So just the western, if you look at the total, BC, Washington, Oregon, California combined, we do over 50% of the total North American production. Just another slide giving you the different numbers. I better keep moving. Randy, this is for you at the bottom there. We're GMO free. Sorry. So all the health benefits, there's just so much good news with blueberries. Every time there's health benefit research, be it cardiovascular health, brain health, diabetes, or cancer research, a lot of positive stories coming out. So we're gonna now talk about our operation, Westbury Farms. That's our website there. So the industry, as I mentioned, it's 170 million pounds, and Westbury, we pack over 5% of that production. So we're not just us, the whole industry is global. So we ship right across Canada into the Midwest, into the Chicago, New York market, and abroad, into Japan, into Korea, into China. China has become a big, big market. Last year, they bought about close to 100 million pounds of fresh. So we need those opportunities in markets to sell all our blueberries there. So I'm just going to give you a little bit of the landscape. We're in Abbotsford, in Matsqui Flats. You're overseeing parts of Mission. So that's organic acreage there. You can see the drip irrigation and the mulch and the hilling there. It's a nice shot with Mission in the background. So from harvest, all our fresh is hand harvested into these flats. It's brought into the packing plant, dumped, graded. We got advanced technology. You got color sorters, soft sorters to take out all of the fruit that's objectionable, and packed into these clamshells. And for organic, there's our organic label. We are certified for the export market, so we carry not just the BC check, but also the Canadian label and the USDA label for that. Our packing facilities. And now we're going to move on to the organic side. So we started farming or getting into the organic about 6-7 years ago. I'm about $1 million in the hole, so think twice before you get into it. It's finally starting to pay off, but it's been challenging from the financial side. So I just want to share. So that's COABC. That's your certifying body, not the certifying body, but they represent the certifying association, the bodies that we go to get certified. So I just want to define organic farming. What they're saying, organic farming promotes sustainable health and productivity of the ecosystem. Soil, plants, animal, and people. Organic foods are, what does it say? Farmed in an environmentally sustainable and socially responsible way, focusing on soil regeneration, water conservation, and animal welfare. That's one definition, but there's slight variations of these definitions. So, and then what is organic produce? What is that when you say we're growing organic produce? So simply stated, organic produce and other ingredients are grown without the use of pesticides, synthetic fertilizers, sewage sludge, genetically modified organisms, or ionizing radiation. Animals that produce meat, poultry, eggs, and dairy products do not take antibiotics or growth hormones. I'm going to just leave it. Anybody thinking of getting into farming or into organic, just some of the considerations that you need to go through. Certification, we are certified, and so it's a process that we went through. It takes 36 months to become a certified grower. It's a bit of a lengthy process. You fill out your paperwork and all that, and they'll send out an auditor. They'll audit you, and if everything looks good, you will move forward. And this is an annual process, and not just one time, so we have to go through it every year. And these are the two logos that we carry because we're in the export market. Environmental sustainability, I just want to share bits and pieces of this as it pertains to our farm. So we'll talk about the water, soil, and air, the conservation side of it. Want to now define sustainable agriculture is the production of food, fiber, or other plant or animal products using farming techniques that protect the environment, public health, human communities, and animal welfare. So as you know, sustainable agriculture integrates three main goals: environmental health, economic profitability, social and economic equity. Sustainability rests on the principle that we must meet the needs of the present without compromising the ability of future generations to meet their own needs. So I'm going to use irrigation as an example. Water, wise stewardship of water resources can help to diminish the effect on agriculture practices on availability of water resources and water quality. So on the availability side, just using irrigation as an example, how it all leads to conservation. Number one, well, you see drip irrigation there. Used to be all overhead, but no longer for food safe reasons. Everybody's gone to drip irrigation, and also for water conservation. And proper planning, management, and operation of your system is very crucial to save water, and scheduling, timing, of the application. Last year, we obviously, as you know, we had a drought, and we're on surface creek water. We're very lucky we didn't run out, but there are other farms that did. Those fields got scorched. And we use mulches, which is sawdust, to reduce water evaporation, and you can get into storing runoff water, recycling, etc. On this side now, it's the on the safety aspects of it. Our plant is HACCP certified. Our growers are now all getting Canada GAP certified. The retailers want our suppliers to be third-party audited. So that's where this whole food safety programs have gone. A lot of growers have environmental farm plans, and to enhance their natural resource and reduce possibility of accidental harm to soil, air, water, and biodiversity. How am I doing for time?
3 minutes left.
Oh my. Okay, drip irrigation, as I mentioned, that's what drip irrigation looks like. Is below the production line. And so not just water application, but we can do nutrient application through that also. Just another shot of that. I have 2 creeks running through our operation. So the riparian zone, the protection, the biodiversity that's created there. Talking about, the regulation side of it. Water, it's not free water. We pay for it. It's licensed. We have to get a license. And that's becoming more and more important. And then getting into the Fisheries Act, with my, say, 2 creeks, prohibiting obstruction to fish passage. The Act says it requires water intakes to be screened to protect fish, requires approval for work that may impact fish habitat. So this is on the air side. We're very fortunate with farming blueberries. You have, it's minimal dust or other contaminants. It's not plowing or disking our fields. We have sod planted in between the rows and all that, and so, but there's some areas where ammonia, volatilization from animal urine, manure, fertilizers, talked about the dust, and open burning. That used to be a big thing, but with the municipalities getting more and more involved, it's not so much of an issue anymore. And so on the soil side, our soils, we have from peat to sandy loam to clay loam soils, and they all require management in different ways. But we use on our blueberries these weed mats to control weed, obviously, and mulching. The sawdust helps quite a bit, but as you can see, that's a cover crops reduce soil erosion by planting sod between blueberry rows, reduces soil rutting, improved equipment traction, reduced dust and mud, increased organic matter, reduced compaction. Just a couple of more shots of that with the crop cover. And soil erosion on water courses, the vegetated riparian areas, creek bank stabilization. There you see that on the right-hand side. We need to do some more work on that. There's where we've done some work, stabilizing the bank. And there's some more field shots. And I think I'm running out of time. Ah, that's it. Perfect. Oh my. Thank you very much.
Well done, farm.
So I got a 5-minute extension without any blueberries. So, anyways, I want to thank Genome BC for organizing this session. I think everyone knows that feeding the planet is certainly one of the grand challenges of the 21st century, and we have to figure out how to do this in an environmentally sustainable way. And if you can't hear me, please, because I have the softest voice. In fact, people make fun of me by going. So I think Ricky laid out the problem very, very well. We have the population of the world continues to expand in an alarming way, and the land base for agriculture does not. And I think you all have heard the estimates. We need to increase food production by about, or increase the number of calories by about 70% by 2050. So it's a pretty amazing challenge. And of course, we have to do this in the face of climate change, which is expected to reduce crop yields in most of the world, in most tropical and subtropical climates. In Canada, we'll be able to produce more food, but actually our land base is quite small relative to other areas of the world. So it's a tough challenge. And as Parm pointed out, one of the big problems is water. Water stress is expected to increase, particularly in some of the most rapidly expanding areas of population size, like in India and sub-Saharan Africa. And water stress, drought stress, is actually, if we look at both biotic and abiotic stresses, biotic means things like diseases and so forth, and abiotic stresses are things like drought stress and salt stress and so forth. Drought stress alone is responsible for 50% of all yield losses due to both biotic and abiotic stress. It is the big one. And there are lots of, and Ricky pointed out there are lots of different ways, potential solutions to this problem of feeding the planet. I always think the easiest one, if we could just convince everyone to be vegetarian, we'd be there. But people like their meat. So we have to come up with other solutions. You know, food wastage is another one, is one problem. Randy has mentioned GMOs are one way we could certainly make some significant progress. There are a lot of different approaches. And farming practices, as Parm pointed out, are another approach that we can certainly increase yields. But one approach, I think, that is going to be part of the solution is simply to develop more productive, environmentally sustainable, and environmentally resilient crops. And again, there are a lot of different ways to do this. GMOs are one. One approach that we're taking, which has become quite popular, in part because of regulatory reasons where we, in many cases, can't take advantage of GM approaches, is to tap into the genetic diversity of the wild relatives of crops. And so to give you a little background, during domestication, early farmers selected mainly for increased yield. And as a consequence, a lot of useful diversity was lost, particularly diversity relating to tolerance to various, to drought stress and salt stress and to various diseases. And this was intensified by modern improvement. And so there are quite a number of breeders, not all of them, that would like to sort of reach back in time and get some of this diversity from crop wild relatives. And one of the things that's happened is there are new genomic tools and computational tools that allow us to do this much more efficiently and precisely. We're talking still about sexual breeding, conventional breeding, where yes, you can get some big surprises, and I'll show you. But some of those surprises can be advantageous, others not so much, as was pointed out earlier. And this has been this is not something new. This has been going on for centuries. In fact, one of the real success stories is this rice grassy stunt virus that was basically decimating rice crops in Southeast Asia. And so there was a huge effort by IRRI, which is the International Rice Gene Bank in the Philippines. They went through literally thousands of accessions of wild rice. They found one that actually conferred resistance to this virus, and now it's no longer a problem. But there are lots of other uses. These range from disease resistance, adaptation, to drought, cold, salinity, nutritional quality, and so forth. And in fact, in 1997, the benefits from these wild crop relatives was estimated about 115 billion annually. And so this has been done before. The big difference now is that we have to do this in a systematic way and much more efficiently. And I'm going to give you an example from what we're doing in sunflower. This is not the only. Sunflower is actually a pilot project. That's the Global Crop Diversity Trust, which is in Bonn, basically has a $60 million project to adapt crops to climate change, and sunflower is a pilot in this. And I'll sort of show you what's going on. So This is sunflower, and just to give you an introduction, it's a global oil seed. It's worth about 20 billion annually. The hybrid seed market is second only to maize, so it's a hybrid seed crop. That means that you take inbred lines and cross them to produce F1 seed. And hybrid plants tend to be more resilient to both biotic and abiotic stresses. It's considered to be a priority food security crop. It's actually the only oil seed on that list, and the reason is it's used primarily for food. It's a healthy oil seed and healthy oil that can be grown in many developing world climates. And it's already somewhat a drought-tolerant crop. It can be grown sort of in secondary marginal soils, so it's already quite widely grown. Basically farmers will grow maize and soybean in the really good soils, and then sunflower in sort of the worst soils. And this gives you an idea of the production of sunflower relative to other well-known food security crops. It's about the same size as cassava and potatoes and chickpeas. It's dwarfed, of course, by wheat. And if you were to put all sunflower production in the same place, it would be about the size of the state of Oregon. By the way, this is Walter Anyanga. He's one of our collaborators in Uganda. We'll talk more about some of the work he's doing. And so these are the wild sunflowers. And one of the reasons why this method works very well, this approach is working well with the wild sunflowers, is that there's probably no other crop that has as many wild extremophile relatives that you can actually cross and have sexual reproduction with the cultivated sunflower. And so I'm showing just a few of these here. This is the silverleaf sunflower. It's found on the coastal plain of Texas, and it's both drought and salt tolerant. This is the desert sunflower found from the Great Basin deserts in the southwestern US. This is the paradoxical sunflower. This is a rare and endangered sunflower in New Mexico and Texas. We just found another population in Mexico that's far larger than anything in the US. It's a really amazing, and this is very, very salt tolerant. These are saline marshlands. The water here is more salty than can be found in the ocean. This is my favorite sunflower. It's called the anomalous sunflower, but as you can see, it's sort of it grows on sand dunes, and sand dunes have almost no nutrients at all. And so this has very high nitrogen use efficiency. Now, most of the big agrobiotech companies that breed sunflowers, they don't really care about low nutrient resistance because they like to sell the fertilizers as well. But in developing countries, often they can't afford to buy those fertilizers, and so something like this sunflower offers a lot of benefits. So I'm going to just very quickly go through some of the science here because I expect that I think Randy's, everyone else's talks are probably a lot more interesting. But anyways, I'm just going to give you an idea of the very, what we're trying to do is to do this in a very systematic way. So there are 22 wild sunflower species that you can cross with the cultivated sunflower. And so basically what we did was we sampled all of them, we sequenced their genomes, and we made a tree. Okay, and so this is what's called a splits tree, but essentially what it means is that it also takes into account when you have hybridization between different lineages, and so that's why it's not your sort of perfect tree. It's more of a realistic view of how evolution really proceeds. And so what we did was we got this tree, and then we took it, we looked at it basically, and we took 25 samples from that tree that represent all of the wild diversity, and then we create what we call Prebreadlines. Essentially all we're doing is we're taking these wild donors and we're back-crossing them into an elite cultivated line. And then we sell for several generations to make it so that those prebred lines breed true. And then these are the ones that we then use for evaluations. And we created about 400 lines. And I should say this is quite a bit of work. We did this at UBC, but the USDA, which has a big sunflower breeding program, they've created about 70 or 80 prebred lines throughout the entire history of the USDA. For the last 50 years, we did 400. And this is the person who did it. This is Greg Bowdy. I was just fortunate that he came to my lab. His dad is a maize breeder in Ontario. And so I get this fellow in my lab, and he knows how to do this stuff, which we really didn't, because we don't really normally do breeding. And so these are some of the students at UBC doing the work. And so this is just some data. So what we do in this case is we're using genomics to make plant breeding, traditional breeding, more efficient and precise. So here what we're showing here is this is just a single chromosome, chromosome 1 as it turns out. And then along here and we're sort of just looking across this chromosome, and the yellow region just indicate for a particular prebred line what part of the genome might have come from the donor. So the yellow is that's coming from the wild species. So we know for each of these prebred lines exactly what parts of the genome, what genes are coming from the wild donor. We also did some evaluations. This was with collaborators in Uganda and Europe and the US. And so this is Walter. So our biggest evaluations have been done in Uganda, where sunflower is widely grown. And so what we did was a drought evaluation in Uganda. And Walter planted out the prebred lines at 3 different locations that differ in the degree of drought tolerance. And the results actually were quite stunning. You can see here, this is the most drought tolerant site. And basically, this is the typical cultivar, the elite lines we were back crossing into, dead. But you can see that some of the lines, with just a few introgressions from the wild germplasm, actually do just fine. And so Walter now is moving these chromosomal segments into his cultivated lines. There also were some real surprises. So sunflower is an oil crop. That is, it's produced for its oil that's eaten. And the cultivars have about somewhere between 40 and 50% oil content. The particular line we use has about a 45% oil content. The wild species, generally from about 25 to 40%. So some of our prebred lines actually have up to as high as 56% oil content. That's a 20% increase relative to the cultivated line. And what this means is there's cryptic variation in these wild relatives. In this case, we get a princess rather than a, what did you call it, an axe murderer? Yes. Of course, we did get some axe murderers as well down here. As you can see, these are absolutely crummy. But what it means is there are these hidden cryptic variations, so you can get some huge and very positive surprises. And so obviously, this is a $20 billion crop, a 20% increase in oil. It's sold for its oil is non-trivial. And also will produce a lot more calories. So, what happened to the... So I got that out of order here. What we're doing now is, so when I've given this presentation to breeders and to representatives of major agrobiotech firms, and they always say, well, these wild traits, they're going to have all sorts of other adverse effects. And their basic argument is you can't have your cake and eat it too. And I actually think that you can have your cake and eat it too. And so what we're doing right now is we're actually looking to see whether these particular traits, like the drought tolerance and the oil content, actually do have the negative side effects that some of the companies predict. I should say it's mainly the major agrobiotech companies that are skeptical. The sort of smaller sunflower breeders, they're just digging into this material. They're very excited about it. They're going to town on it. And the public breeders. But I get skepticism from the Monsantos and the Syngentas and the DuPonts. By the way, sunflower is not a GM crop. It's a competitive advantage. Otherwise, we probably wouldn't compete very well against canola, for example. All right. So just to conclude is that what I'm trying to convince you, I don't think it takes that much convincing, is these crop wild relatives do represent very important new sources of variation for agriculture. These plants have survived repeated and extreme environmental challenges, and yet we just haven't tapped into their resilience and adaptive capacity. And sunflowers, I think, can provide an example of both the expected and unexpected benefits that can be obtained from such germplasm. And the important thing is that genomics and computational technologies allow us to do this much more efficiently and precisely than in the past. So, thank you.
You setting up the panel?
did promise diverse perspectives, and we got them. Pretty diverse, yeah, that's good. So really, you can come up now. Don't be shy. Well, this is sort of like, I don't want to be associated with them. No. Actually, do you want to do a little, the designer in me wants us to have a little, there we go. And we apparently have two wireless mics that we're going to have to share and be collaborative around, so don't fight over these. Although, can you hear us? Yeah. Thank you. What's that? Ah, that is a very good question. Do you want to answer that one right off the bat, Lauren?
Sure. So, is this working? Yes. Okay, so genetic engineering just means that you're using recombinant DNA technologies to splice material from other species into your DNA. Genomics is simply a broad technology of any way to sort of look at the genome and manipulate the genome. So it can be used for both, it's a much broader term. It can be used for both conventional breeding, but the information from genomics can be used for genetic engineering. For example, the genes that we find in sunflowers, we could take a mutation that we see in one of these wild relatives and use it to make soybean more drought tolerant with a GM approach. And now I should, I don't know if you've heard about the CRISPR-Cas9 technology. It's a new technology that allows you to make things far more precisely than in the past. It used to be we would have to take a gene, the entire gene from another species. Now, you don't have to take anything. All you need is the information, and you can make the exact mutation that you want. And it's absolutely untraceable. Gene editing. Yeah.
Okay. I'm going to take it. While you're thinking about your questions, there's your mic. So formulate. I'm going to take it up to, I guess, a slightly different level to ask about if you were in charge of providing us, and you can choose whatever level of government you want, provincial, federal, even local, and you could enact a policy that would actually think in a very future way about environment and climate change. What would it be? What would you advise? Make something happen. You're going to hand it off to Randy.
I promised not to talk about GMOs, but I would suggest that the public's trust in this technology might be enhanced if Health Canada were to take testing of these new products, these novel products in-house. At the moment, I believe that we more or less depend on industry to do the testing and then submit their information to the government for approval. And I think that more in-house testing might engender more trust from the public in the product.
Yeah, I guess from a food perspective, with climate change and environment and things like that, we're really looking at how do we ensure that the, public gets a nutritious food supply, right? And because that's one of our biggest challenges right now. You look at some of these disease states, and it's traditionally, and I think historically, if you look at the statistics, it's people below a certain economic status. And so how do we enact a policy that ensures that we get food, nutritious food, to the right people? And so if we talk about food policy, we're talking about price policy too. Why is it that people can buy 4 liters of pop for way less than 4 liters of milk? And if you're looking at families who are struggling to get calories into their family, you know, I guess they're forced to have those kind of decisions. It's not a decision, really. They buy the cheapest food they can, which is probably less nutrient dense.
Okay, just adding to that, on the food security side and the food safe elements, you know, the consumer is the driving force behind all of this. Learning from the Green Revolution, Rachel Carson, the Silent Spring, and we all awakening to that. And now when we talk about GMOs, it's the unknown that scares everybody. And to enact policy around ensuring food security and safe food is a huge sector and something that we need to be addressing.
So from my perspective, I'm not a big fan of more sort of legal restrictions or so forth and more policy. I think I would rather see more done in the way of education to basically training of how to have healthy farms, environmentally sustainable farms, to encourage, you know, borders with wildflowers for pollinator health, and to reduce the use of water, or to save water, and so on and so forth. And so to me, a lot of it, and even in terms of breeding, you know, to make the best varieties available for farmers that require the fewest inputs, external inputs, and so forth. So for me, it's not so much policy, but the government actually trying, or universities, doing what was done perhaps 50 years ago, like in the land-grant universities in the US, where there was this extension program that was so involved with farmers. And I don't see that as much in Canada. Instead, they seem to be cutting the breeders, cutting the extension services, and so on and so forth. But you might, I don't know exactly what's available to you for your blueberries. How much help do you get, or is this something that you do as a community?
What we're finding over time, the government's been stepping away from. Look at all the research stations that we used to have here, and we now, as a good example, the blueberry sector, our association, we fund, it's a mandated board, and we fund 3/4 of a cent into this pool, and a lot of times it is matching funds from the federal side, but it's a difference from 20, 30 years ago. We're actively participating in that research, and then maybe there's advantages to it. We're also guiding it.
Turning to the audience.
Okay, thank you. Thank you to the panel. It was very interesting presentations. My question is about CRISPR. The genetic engineering to date has been largely the bailiwick of the large agri-food companies, expensive to do. They promoted it to often promote other products such as Monsanto Roundup. But that's going to change. And as CRISPR allows more precise engineering and lower cost, I'm just curious how you envision this might modify the whole agri-tech industry going forward.
Yeah, so it's an interesting thing. The big agrobiotech companies have actually, basically the governments came to them and said, how should we regulate this, and what experiments should we have to, what experiments should we require you to do? And so the big agrobiotech companies made it very expensive to actually introduce a engineered crop or a new transgene. And it's basically, so it meant that only a handful of companies could afford. It's like a new drug. And it cut down, it resulted in a complete shutdown of creativity in the academic sector, because no one could afford to actually introduce any kind of a GMO except for a handful of big companies. I think CRISPR is an interesting thing because we don't know yet how it's going to be regulated. And it's certainly, if it's regulated in the same way as GM crops have been in the past, then again it's going to cost $50 million to introduce a new CRISPR variant, a new mutation, and universities and public breeders won't be able to afford it. On the other hand, you have places like it's untraceable, and so my worry is that if the regulatory burden is too high, people will just do it and won't tell anybody, because you can't actually see what. So there's all sorts of things can be done. I mean, right now you could, and it's a very different technology, because you can take information from, I think it has huge implications for sharing of germplasm and for the convention, the International Treaty of Plant Germplasm Resources, because it's the information that's valuable now. You can take information from maize or corn, and you can then use that to change rice or so forth without ever taking a gene. So all you need is the information on the wild germplasm. You actually don't need the gene itself or the germplasm. So it's revolutionary in many different ways, and it's going to, you know, how it's used is really going to depend entirely on how the regulation proceeds.
Yes, I meant to say, please say your name so we have a context.
Jack Woods.
Jack Wood.
Thank you, Jack.
Hi, I'm Amanda. My question is, what are some of the effects that BC farmers are currently seeing from climate change, and how are they preparing for the changes that we're going to see in the future?
I take it that's for me. Well, last year, it's a very good example of what happened in the industry sector, and taking blueberries as an example. Right across the spectrum, there were people like us were just at the borderline. We're just irrigating basically around the clock, and sadly, there were other fields where they ran out of water, and the fields were just scorched. And so I talked about licensing. You're going to find that becoming more restrictive. Not only that, but we as growers getting more proactive. I mentioned drip irrigation used to be overhead. Lots of surplus water. So we're going to have to start micromanaging and really getting down into using all innovation tools that we have as growers, and then bringing in additional regulatory reform into the sector to continue to move forward. Well, I guess in the West Coast, we feel that we're never going to have water shortage, but it's there. And then when you look at places like California, where they're having to take out some of those crops that require a lot of water. My father farmed there in middle of in the Sacramento Valley there, and your peaches and prunes was open irrigation. That's all changed to micro. We never thought about that at any given time, but that's reality. That's what's happening.
Randy, you talk.
I do talk to a lot of farmers. I think one area that we hear concern about is that while climate change affects Canada in some positive ways, I mean, we actually maybe have a climate more conducive to crops that we haven't been able to grow successfully. The way that it's shaking down is we're seeing more precipitation on the coast, but much, much less inland. So even if the temperature band is more conducive to warm weather crops in British Columbia, the absence of rainfall, the reduction in rainfall in the interior is going to be a seriously limiting factor. And I think lots of orchardists and farmers in that region are already concerned.
Amanda, can I pick up on your question? I think we're seeing quite a huge shift in all of our perceptions about climate change. How do you think we should be, I guess in a sense, capitalizing on this to really mobilize everyone around the different challenges, whether it's in the agricultural sector or the energy sector, Because we're talking now about the sustainability of our economy in a variety of ways.
You know, the $7 cauliflower is an opportunity. You know, $3 lettuce is an opportunity. These are crops that have been largely abandoned in British Columbia. We've allowed California to grow them for us, and at this point, it doesn't look like California is going to be able to continue to play that role, not for the entire of North America. I mean, a massive, massive amount of food comes out of California, and it's dropping, and it continues to drop with every year the drought carries on. But, you know, if cauliflower is suddenly twice as expensive, well, maybe farmers in Surrey, you know, possibly take out some of their blueberries. You never know. They used to grow quite a lot of lettuce there, and the Fraser Valley did have a lot of cold crops as well. But you know, we've shifted away from that and allowed California to carry the bag. We could take that business back.
So why aren't we? I'd like to hear, like, why aren't we as consumers saying, you know, I want to buy BC.
We haven't invested in the breeding of varieties that are good for BC.
So that would be a good step.
Our real estate prices are too high.
Yeah, somebody wrote a story about that just the other day for the Vancouver Sun. Yeah. Interestingly, the closer that you get to Vancouver, the more likely it is that the cost of land, even inside the agricultural land reserve, will be anywhere from 2 to 7 times more in value than the value of the crop that can be grown on it. That is to say, the land prices, the value of the crops cannot support the land prices as we get close to Metro Vancouver, and that is even though, you know, the ALR has been pretty strict, you know, and it's been stricter yet in the last few years about allowing land to be removed. It's still subject to a great deal of speculation. I think upwards of 30% of the land that's owned by non-farmers is owned by holding companies, and these are companies that are banking on something changing in the future that will allow them to make millions of dollars doing something other than growing cauliflower.
I guess that's Richmond. You got, I mean, that's where the blueberry industry started, and you got a lot of the old genetic material there, and but it's not being farmed, it's just being held onto. So I want to go back to the early 80s when NAFTA came in. We on the highway corridor in Abbotsford there, you had all of these processing plants. And what went out first? It was the field crops. It's just dollars and cents. I mean, as we know, the U.S. economy is 10 times our size, and our input costs, and what Randy just mentioned, just give me an example on blueberries. A mature acre of blueberries is going for $100,000. You go across the line, even though in Linden and all that, it's the Canadians that have driven up the land prices there. It may be $25,000 an acre, but if you go further in Oregon, if you go into Michigan, it's like maybe $10,000, $15,000 an acre. So how do we survive competing with them? And we mentioned Surrey. Surrey, you had some of the best muck soils for growing onions, carrots, cauliflower, lettuce. Again, same thing. We just a very small sector. We just couldn't compete anymore. But so.
Please come down, because I also have a burning question. So after you.
Hi, my name's Jordan. I guess I work a lot with just personal private residences here in Vancouver, and I try and encourage each of my clients to start their own vegetable garden. But I find that a lot of them feel like it's too much work, and it's something that they wouldn't be able to handle doing. And you know, it's just a small plot, like 10 feet by 4 feet, but they can't even comprehend doing that. They'd rather go to the grocery store and just spend money. But I guess my question is, how do you educate people to grow their own food and encourage that? It's a pretty simple task once you take it on, but it's just a matter of some simple education. So I guess my question to you would be, how do you get that out to the general public and encourage these people to do that?
The media might be able to help.
Yeah, maybe.
Are you a yard farmer?
No, I do irrigation installation.
Yeah, because there is a sort of micro industry of yard farmers out there in Vancouver.
Yeah.
And I think what happens, what I've been told, is that when they convince one homeowner to tear up their lawn and plant vegetables in the front yard, everyone in the neighborhood comes around and asks what's going on. And they can see that it's not the homeowner doing it. It's, these young men and women are farming these yards. But what happens is the next season, there's two more because, why don't I want, weekly vegetables for free and somebody else to take care of my yard for me? So, these things, they pollinate, they spread. As soon as it starts to happen in your neighborhood, you can see it start to spread. And there are certain blocks, certain streets in East Vancouver where, you'll drive down and see like a dozen front yard gardens. So, it's just a matter of getting that image out there, and
Just a matter of
put it on
time,
Facebook.
basically. Yeah.
Yeah.
Okay.
Jordan, one of those things that we've tried to do is, we've been working with elementary school kids to start to appreciate food at a very young age and to take ownership over what they grow and pride in what they grow. And then you should see these kids. It's amazing, right? It's like an epiphany that they go, wow, from this seed comes this crop, and from this crop we can make this food, right?
Yeah.
And so we have to start young.
Yeah, I've been a part of building a couple of gardens up in North Van at Lutat Park and Lutat Farms, and it was just basically taking over the whole field and turning it into a giant raised planter.
So your clients aren't wrong. It is a big skill set, I'm very lucky. I live on an acre, and I have about 2,600 square feet of garden, including sheds and a greenhouse. But the number of failures is at least as long as the number of successes. Nature conspires against you all the time, and you really it takes years to figure out how to do it on your particular piece of land. And if people find that daunting, they probably should. It's very easy to bite off more than you can chew when you put in a garden.
Yeah,
You can see when people do it themselves and lose the drive, lose the energy, that it turns into a horrible weedy mess very, very quickly.
Yeah, true.
Just very quickly, I feel there's a trend towards that as we are seeing the consumer wanting to buy local, wanting to know where the product is coming from, how it's growing, and you're seeing more and more these community gardens out there. And I think it's only human nature that what Randy said, when you have a cauliflower head at $7, there'll be a tendency for them to start looking at that, and it'll add on to our food security also.
I just want to say that I'm noticing what for me is a very hopeful trend in our students, and in particular, business students, but all across the campus. They're now thinking about making jobs, not taking jobs. And to me, I think part of the environment that we can be encouraging them is in thinking about businesses that have to do with local food production. So it's like the business when, maybe I could do this. So I think that it's about us talking about it more, but I think it also needs us to think in a more innovative way from a public policy perspective in what we invest in. We need to think differently about taking some, what we might consider risky investment with our tax dollars to actually get things moving. So I think there's a need for us to be way more, risk tolerant if we want to actually do what you're encouraging and what I think we're saying is a good idea. Ian, do you have a question? Is that why you moved to the edge?
Yeah, okay, sorry. I do have a question, actually, and it's going back to the presentation Ricky gave at the beginning, which I thought was really good from the point of view of global trade, movement of food, etc. It seems to me that we see it on one side. I look at it from the perspective of being in an affluent country, and I can get blueberries or tomatoes year-round, and that's really great, you know, and that's technology on one side. But what about our social obligation to be helping feed those countries that don't have it? I mean, we've pushed for a long time with the Green Revolution, self-sufficiency and stuff like this, but maybe we have a moral obligation to be more aggressive on that side and be working to that. So that's one side. So it applies to security. But there is also the food safety. And you were touching upon, which I thought was very interesting, nanotechnology, genomics, and how that can work. We're talking about biosensors in packaging, et cetera, on the food safety, diagnostics. Would you comment on some of those areas and how technology can play a really important role and our social responsibility to the world generally?
Well, thanks, Ian. With regards to nanotechnology and biosensors, you know, this is a wonderful invention, I guess, and a wonderful discovery of how we can ensure safe food. Because, you know, I think to the time when I was a kid, again, you know, it was really the rolling of the dice on certain packaged foods. You didn't know whether or not there was a pathogen in it or not, or whether it had been spoiled or the package had been compromised. Now with these biosensors, we can actually determine that kind of thing. How we translate that to, you know, global partners, you know, it's a big cost factor now. You know, if we can get the cost down, and this is the problem with food, right? It's so sensitive to price point. You know, I'll tell you an example, Ian. When I was involved with this research network, we had, I guess, discovered a new delivery platform, and this is for a fatty acid, and it was better than the existing platform. And we took it to a company, and you know, they identified that it was better than their technology. But they said to me, you know what? We're going to put it on the shelf because the price point is a couple of cents more, and that's going to be the determining factor. So you know, that's the kind of sensitivities we have to deal with in the food area.
So one comment just on your comment about the fact that now, you know, food is being transported worldwide and so forth. And we did a study recently where we looked at sort of the diversity of national diets around the world, and everyone's food diets are becoming much more diverse. Whether you're in Africa or Australia or Asia, you're eating a lot more different things than you were 50 years ago. What's interesting, though, is that we're all converging onto a single global diet that's dominated by Western staples. And so it's sort of put us in, I think, a much more dangerous situation in the sense that we're all growing a lot of corn, we're all growing a lot of wheat. And so if there is a food crises now, and they used to tend to be local, and now they're going to be global in the future, I think, because of the homogenization of the world's diet. I'm not sure. I think it would be better. And part of the reason is you can get much higher yields with corn than you can with the local, you know, teff or whatever grain you're using. And so it's this, you get the calories, but it's, yeah, so I don't know what the answer is.
Well, I was going to say that we're extremely spoiled in North America with regard to food prices. It's typical in countries outside of North America to pay 3 to 4 times the proportion of disposable income on food. So this convergence is going to make food much, much cheaper in a lot of countries. It's also going to make them look and feel a lot more like us, which with the same diseases and problems. So yeah, that convergence is, it's maybe going to be a little bit less expensive for them to feed themselves, but you know, maybe they'd better build a few hospitals in the meantime.
There we go, final words. 7 bells. Oh, sir, do you have a quick question?
Well, nothing's really quick. This panel has so many good answers. But I'll have a comment and a question. I think everything is linked, and I think if you're right about we're moving to single food production, and if you look at the worldwide rate of diabetes, as we move there, diabetes is the thing we have to really deal with because we're all moving to such a poor Western diet. But that's not my question. That's just a comment. You know, I hear a lot about food security and safety. Well, the real problem is water scarcity. And so could you comment on around the world policies on water scarcity, and particularly in BC where, you know, you're very good to talk about micromanaging your water, and And that's great, where we have whole other industries that they take swimming pools and they pollute them, they dump them back in, and we don't seem to have regulation, or they don't seem to self-regulate. So what about the policy of dealing with water scarcity and true water management in this topic?
Yeah, I'd like to hear that too.
I like a good question.
Well, if the petrochemical industry in British Columbia expands, we're going to have a real water crisis because some of those industries are very, very water intensive.
One final comment. Drought tolerance is the world's most important trait.
Ding, ding, ding.
I'm sure, where did you go?
I'm over here.
You can probably engage them when they come down to the back of their seats. I want to really thank our panelists and thank you. Our audience. And just a little reminder, next Tuesday, our April 19th session on food security and sustainability, BC and beyond. So we've got another lineup of great speakers. And then the final session on April 25th, food for thought and opportunity for interaction. We have, on behalf of Genome BC, some gifts for our panelists. So we have to take this back now. So I deliver.
Thank you.
They look cute. They're little USBs plus something that's a joke.
Possibly whiskey?
BC whiskey with BC grain.
So thank you, panelists.